Hi, I'm Ihan, under the supervision of Dr. Adams Kong, and my FYP project is on the de-identification of profile pictures while retaining facial features using GANs. Here is a brief overview of the contents I'd like to go through. In this work, we aim to generate de-identified images of individuals. We define an image to be de-identified when it is at a sweet spot where people familiar with the person cannot recognize them, while strangers find it indistinguishable from the original image. We call this goal unrecognizable to friends and indistinguishable to strangers, abbreviating it to UTF-ITS. This is inspired by celebrity lookalikes, where two celebrities resemble each other but are not biologically related. For example, we see that Zoe Deschanel on the left and Katy Perry on the right have very similar facial features. The practical applications of this project include situations where individuals are required to reveal their likeness without having to reveal their identity, such as dating apps or online forums. This allows users to retain anonymity while being able to review their image. Before we begin the overview of the architecture, we want to highlight two different pre-trained networks we use in the project. The first is NVIDIA's StyleGAN, a progressive growing GAN architecture with a focus on the generator model. It is trained on 70,000 high-quality images scraped from Flickr. When you feed the StyleGAN generator a random latent code, it will output a photorealistic image. The second is a residual network that was pre-trained on pairs of latent code and their corresponding image generated from StyleGAN. This allows us to reverse the effect of StyleGAN, where we input a reference image and we obtain the best estimate of its latent code. In our architecture, we have two sequences. In the first sequence of events, we feed a reference image into the pre-trained residual network to obtain an estimate of the latent code. We then feed the latent code into the StyleGAN generator to give us the first iteration of the de-identified image. This image is usually very different from the reference image but does retain some high-level features. In the second sequence of events, we aim to iteratively converge the de-identified image towards the reference image. We input both images into a pre-trained VGG16 network model to obtain a feature vector and then iteratively perform L2 loss between two feature vectors, backpropagating the gradients through a generator model. At each iteration, we update the latent code estimate, which brings the de-identified image closer to the reference image. Next, to achieve our goal of UTF-ITS, our approach consists of three experimental phases. The first phase allows us to determine the UTF-ITS threshold with the help of a survey. The second phase allows us to improve the image generation process by fine-tuning the parameters. In the third phase, we will compare our results to related work and survey respondents to determine if our goal is met. In phase 1, we would like to determine the identity switching threshold, where people fail to identify individuals. In order to quantify the degree of similarity between faces, we use Google's FaceNet model to determine the L2 distance between two images. We can see that the two images of the same person have a FaceNet distance of 0.489, while two images of different people have a FaceNet distance of about 1.212. Next, we showed a series of images depicting different iterations to respondents and asked them to select the point at which identity switching occurs. From there, we find out what is the corresponding FaceNet distance required. We obtain a FaceNet threshold of 0.909, meaning that as long as images have a FaceNet distance larger than 0.909, they will not be identifiable. In the subsequent sections, we strive to generate images that have a FaceNet distance of about 0.900, of above 0.909. In phase 2, we proceed to improve the image generation process by tuning two parameters, namely face mask and the number of iterations. The first parameter, face mask, is a region that we would like to alter throughout the image generation process. The area outside the face mask will be untouched throughout the generation process. This shows generated images without face mask at the top and with face mask at the bottom across different iterations. We can see that for the same iteration, the generated image without face mask has a higher FaceNet distance from the reference image than with the face mask. This means that generated images with the face mask at the bottom is generally more similar to the reference image. Hence, we decided to adopt the face mask because it retains the head shape and the higher level features. The second parameter that to be decided is the number of iterations to achieve a FaceNet distance larger than 0.909. We performed an empirical experiment of 11 different images to determine the maximum number of iterations we can make while keeping the distance above 0.909. The result is that the maximum number of iteration is 3. In the last phase, we will look at some sample image and review the results of the image generation process. Firstly, we can see that the pose and direction of face is retained in the generation process. Secondly, we can see that the generation process is consistent throughout a unique individual. This means that de-identified images of the same person will always look the same. At the start of the presentation, we introduce our goal of UTF-ITS, where we want people who are familiar with the individual to be unable to recognize them, while strangers would find that two images are indistinguishable. We will test this goal by surveying respondents using celebrities to represent people that they are familiar with. Our survey results show that, in general, people found that the de-identified images of strangers to be more similar and de-identified images of celebrities to be more different, meaning our goal of UTF-ITS is met. To further evaluate our results, we also compared it with related works. Here is a research by Facebook that aims to de-identify people in live videos. We can see that our results produce a more natural outcome, retaining the important features like her teeth, eyes, and eyebrows, while fully masking her identity. In another comparison, our approach fared worse. We can see that our generated image contains some noise in the lip area, and the texture of the image is not retained. However, with regards to the retention of features, we can see that the eyes in our generated image is more similar to the original image than their generated image. So some limitations of this approach is that we inherit the biases in the Flickr dataset the StyleGAN is trained on. We can see that the de-identified image of the white male is very similar to the original image, but the de-identified image of the Asian male is less similar to the original image. With these limitations in mind, we propose a few further recommendations to bring this project to greater heights. Firstly, we should train the StyleGAN generator on a more diverse dataset. For example, if we want to use this approach to de-identify Asians, we should further train the StyleGAN generator on datasets containing more Asians. Another further recommendation would be to improve on the survey method. As we did our survey using Google Forms, there might be some miscommunication of the requirements. If we can perform this survey in a more controlled environment, we can obtain a more accurate FaceNet threshold reading. Now, in conclusion, we explored the use of pre-trained StyleGAN generator to generate de-identified images of people. This is done through 3 different empirical experiments where we managed to generate photorealistic images of people that retain low-level features such as their face structure, as well as high-level features such as their pose. Our survey showed that in general, we have achieved our goal of UTF-ITS, but further recommendations are required to produce better de-identified images. With this, I'd like to thank my supervisor, Dr. Adams Kong, for his support and advice throughout this whole project duration. Thank you.